7.6. And we're going to talk about literal equations. And literal equations are simply an equation that has more than one variable. So sometimes we work with formulas like, for example, the perimeter or the area, and they have more than one variable. Now, when we look at these, I'm going to have to tell you specifically which variable to solve for. So we're going to start off with a very, very basic one. And these are on page, we'll start with this one, on page 156. We're going to look at question 73. And they tell you specifically what variable to solve for. Okay, what this formula is this is your distance formula. Doesn't really matter what the formula is, and they want you to solve for the t. We just want to solve this for the t, but this is your distance formula. Now, what does it mean when I say solve? Let's talk about some basic terminology here. When I say solve, like when I say solve for x, what does that mean? The x is on the left-hand side, right? Numbers are on the right. So we want to get that variable by itself. Now, we think in terms of opposites. The opposite of multiplication, again, is division. The opposite of addition is subtraction, and so on. So what are we trying to solve for? T. That means we need to get the t by itself. Now, how do I get the t by itself? What is attached to the t? An r is attached to it. Now, how is that r attached to the t? It's not addition, not subtraction. It's attached to that t by multiplication, right? So what operation is going to undo this multiplication here? Division. So what would happen if we divided both sides by r? See, it's going to work in terms of opposites. I'm going to divide both sides by r. Okay, if I do that, what does that leave you with? D over r, right? And what happens with these r's here? One's on the top, one's on the bottom, and that equals what? T. Now, I usually like to write my variable I'm solving for on the left. So I'm just going to put the t on the left and put the d over r on the right. So all I did was divide. Now, why did I divide? I divided because it's r times t. That's what that means. And how do I get rid of the r? If it's multiplication, the opposite of multiplication would be what? Division. Okay, then I get to here. Now, I like to always write my variable on the left, so I just switch them around. So I put my t on the left, d over r on the right. Okay, let's do another one. Very similar again. 76. Almost exactly the same. Question 76. A equals LW. And I want you to solve for the variable L. Okay, so what I'm going to do is I'm going to find the L, and I'm going to put a box around it. So here it is. Right there it is. Now, what is attached to that L? The W. How is that W attached to the L? Multiplication. So how do I get rid of the W if it's attached by multiplication? Division. So I'm going to divide both sides by W. And then those W's can cancel. And now I've got A over W equals L. I like to write it so that I get the variable by itself on the left. So now L equals A over W. How do I know I can stop? And how do I know I'm done? What am I doing? I am solving for L. Now, what does that mean when I say solve for L? That means L has to be by itself on the left-hand side. Is it by itself on the left-hand side? Yes, that is what I want, so I can stop. You can add more variables to it. Question 81. Same thing again. Question 81. I equals PRT. And I want you to solve for the variable R. Okay, so what am I wanting to get by itself? R. Where's my R at? Right here in the middle. Okay, what is attached to the R? Okay, so I need to get rid of both of them. So whatever I do to one side, I do to the other. So let's divide it by PT on both sides. That cancels and that cancels. So that now leaves you with I over PT. And what does that equal? R. I'm going to rewrite it with the R on the left-hand side. I over PT on the right-hand side. Okay, let's do addition. What about question 87? Okay, these were all multiplication. How do we undo multiplication? We use division. Question 87, we're going to be looking at addition. Okay, so here's the B right here. And so there it is. Now, how does the A relate to the B? It's not multiplied, is it? Right? There's a plus sign in between. So how can I get rid of the A? Okay, it's not division, right? Because there's addition. So the opposite of the addition would be subtraction. And what about the C? How does the C relate to the B? Same thing. It's addition. What's the opposite of addition? Subtraction. Now let's see what's left over. On the left-hand side, none of this can go together. So I'm going to leave this as P minus A minus C. On the right-hand side, what's going to cancel? The A's cancel, right? And the C's cancel. So what's left over? The B. Now, what am I solving for? B. So let's rewrite this as B equals P minus A minus C. And that's your answer. These are called literal equations. And you have to solve for a specific variable. 89 requires us to do two steps. So question 89. P equals 2L plus 2W. Now we need to solve for the variable W. So if I want to solve for the variable W, let's think about how we can get it by itself first. So there's my W. Okay, put a box around it. It's actually 2W. When we solve, we want to get that variable by itself. So what does not have a W attached to it that needs to go to the other side? You need this green box by itself on the equal bar. So what needs to go to the other side? Okay, 2L. So let's go ahead and move that 2L over. Now I can rewrite that as P minus 2L equals 2W. Is everyone okay with that? Moved it over. Now, what's in front of the W? 2. How do I get rid of the 2 that's in front of the W? Not subtract. How is it related to this W? Okay, this is like a 2x. How would you get rid of the 2 in front? You would Divide by 2, right? Because it's multiplication, isn't it? This is said 2 times W. So how do I get rid of that? I divide both sides by 2. Now, you don't reduce it down, you leave it alone. So the 2's can cancel. And that leaves you with P minus 2L over 2. And that equals W. I like to switch it around. So I'm going to put my W on the left. That's just the way I like to do things. And what does W equal now? P minus 2L over 2. Do not break down the 2's. Leave it exactly as it is. Do not reduce the fraction. Leave it just like it is. Because in the later part of this course, you're going to learn how to reduce it down. But you cannot just cancel the 2's out because that's subtraction. So leave it as it is. Don't try to break down the fraction any further. Okay, let's try another one. Let's try question 93. AX plus BY equals C. And I'm going to solve now for the variable y. So I'm going to try to solve for the variable y. Now, what would I want to do? Find the y. So it's here. Okay, so here it is. I want that green box to be by itself. What needs to go to the other side? Okay, the AX, right? That needs to go. The whole thing can be moved over. So subtract off the AX. Okay, now what are we going to do next here? We're almost done. Yep, we need to get rid of the B because we want this y by itself. How does the B relate to the y? Multiplication. So what undoes this multiplication? Division, right? So we divide by the B there. Okay. And what does that give you? Well, the B's now cancel. So now we have y equals, which is what we want. Right? We are solving for the variable y. So y equals now C minus AX over B. And that's it. And we leave it exactly as it is. I only gave you 2 of these questions in your homework. I'm going to work out one of them for you. I'm going to work out the more complicated one. So let's look at your homework. 2.6. We're going to look at question 6 here. This is the formula to convert Celsius to Fahrenheit. Remember, there's 2 different units of temperature. We use the Fahrenheit system. Most of the rest of the world uses the Celsius system. Okay, this is what we've got, and I want you to solve this for the C. Okay, now we've worked on questions like this before. We have a fraction. What do I need to multiply all the numbers by to clear out that fraction? What number's down below? 5. So we're going to multiply this by a 5. So we're going to go ahead and distribute this 5 through. Now, when I distribute this 5 through, what does that leave me with? That leaves me with 5F equals, those cancel, 9C, and then we've got 32 times 5, and 32 times my 5 is my 160. Now, what variable are we trying to find? C. So, here it is, 9C, right there. What do we need to do? Can anyone tell me what needs to be moved over? The 160, right? Because I want to get that green box by itself. So 9C needs to be by itself. The 160 needs to go to the other side. How does it relate to the 9C? It's got addition, so how do I get rid of that 160? I subtract. Okay, so I subtract the 160 off. Now we've got 5F minus 160 equals 9C. What is my last step here? To get the C by itself. Can someone tell me what I should do next? Divide by 9, right? That's going to get rid of the 9 because the 9 goes with the C by multiplication. Okay, almost done. So now we have 5F minus 160 over 9, and that equals C. I'm going to rewrite it because I like to have my variable on the left. So C equals, now when I rewrite it, 5F minus 160 over 9. And we know we're finished. How do we know we're finished here? Okay, we are solving for the variable C, and what does that mean? That means that the C is by itself on the left-hand side. Now, question 7 is very similar. It's easier though. Question 7 is one step. One step is all there is in question 7. And I didn't give you very many of these. We'll do more of them when we get into the graphing section in chapter 3. We have a little bit of time left, so we're going to go on and look now at ratios and proportions. So we're going to move on and we'll work a little bit in 2.7. (2.7) is ratios and proportions, and also percentages too. Okay, so on these we need to set up a ratio, and we're going to learn how to solve these ratios. So we're going to do the equations first today, and then next week we will look at the applications. Now what we're going to learn about is we're going to learn how to cross multiply. So we're going to learn how to solve something very simple, and I'll just make up one here. And I want you to solve this. Okay. Now, we could go ahead and solve this by multiplying everything by a 4K. But when we look at this, we can do a very easy technique when we see fractions like this. First off, do we have any addition or subtraction? No. Left side is a fraction, the right side is a fraction. Now, when the left and the right side are both fractions, we can apply a new technique, and that technique is called cross multiplication. So when the left-hand side and the right-hand side are equal, and they're both fractions, just one fraction on each side, we can do what's called cross multiplication. And we're going to cross multiply here. Okay, so that means we take, when you cross multiply, 5 times the 4 and the 9k on the other side. Let's just simply cross multiply. Right? So 5 times 4, what is that? 20 over 9k on the other side. And how would I solve this? Don't make it more difficult than what it needs to be. What would you do to solve this out? Divide by 9. Okay. And I'm going to go ahead and rewrite this instead of rewriting it and writing it again. I'm going to write this now as k equals 20 over 9. And that's it. That's your answer. Okay, we're learning a new technique called cross multiplication. Let's do another one. So, same concept here. We want to solve it. We could multiply everything by 9. Clear our fractions and then divide and divide again. But there's an easier way. What do we notice? The left-hand side is a fraction. The right-hand side is a fraction. I can now simply cross multiply. So what does that give me? That gives me 9 times the 2x. That's there. What does it equal? 3 times that 5. I was ahead of myself there, so 3 times that 5 there. Now, 9 times 2, that makes it an 18x. 5 times 3, that's 15. How do we finish it? Well, divide by what? 18. And we're going to have to reduce. You must reduce. So x equals 15 over 18. But what does that reduce down into? These both have a 3 in common. So that's going to reduce down now to be 5 what? Sixths. So there's your answer after you reduce it. Because 15 over 18 reduces down to 5 sixths. Okay, let's do another one. This one's a little bit more difficult. How about 5 over x minus 3 equals 4 over 7. Okay, same concept. Notice fraction on the left, fraction on the right. Okay, now when we multiply these together, we may have to use parentheses. That way we remember to distribute. So cross multiply. When we cross multiply, 5 times 7 goes here. And then the other one is 4 times x minus 3 there. And we can solve this. 5 times 7, well, that's 35. What do we do with the 4 now? Distribute it through. And so that is 4x minus 12. Okay. We need to get the x by itself, so I'm going to add 12 to each side. And 35 plus 12, that should make it a 47, doesn't it? Okay, 47 equals that 4x. Now, you could have moved everything around multiple times. I think we're used to this enough now that we know we can go ahead and leave this here, but we'll rewrite it with the x on the left at the end. So I need to finish this out. So what would I do? Divide by 4. And I always like to write my variable on the left, so x equals. Okay, those cancel. And what does x equal? 47 over what? 4. And that's not going to reduce down anymore. Okay, let's do another one. We'll just keep increasing these. They get a little bit more difficult, but not much at all. It's the same steps as we've done before. So this one, how do we work on this one? Well, different ways of handling it. What I would do, and what I always like to do, is if you have a question that has parentheses, I always like to just get rid of the parentheses to begin with, because that's our order of operations. So if I gave you this question here, I would go ahead and distribute that 5 through, just to get rid of the parentheses. You can cross multiply first, but I like to strictly follow the order of operations. So order of operations, parentheses are first, so we'll get rid of those. Now that's going to leave me then with a 15k and a plus 10 over 4, and that equals 7 over 2. Now we can work with it. Cross multiply. Okay, so what do we have? We have 2, use parentheses, 15k plus 10, and the other side is 7 times what? 7 times your 4 then. Now we need to finish it. So we distribute through. So 2 times 15, that makes it a 30. So that's 30k. 2 times 10 makes it a 20. And 7 times 4 on the other side. Well, 7 times 4, that makes it a 28. Okay, and we can solve it. So move that 20 over. And we now have 30k equals 28 minus 20. That makes it an 8. And what's my last step going to be here? Divide by 30. And we got to reduce, because these reduce down. And what does that leave you with k equaling now? These are even numbers, so 2 is going to go into both. So 8 divided by 2 is a 4, and 30 divided by 2 is a 15. So there is my final answer there. Let's do one more, and then we'll look at how to compare ratios. So let's look at one more. And we'll make up something kind of like what you got in homework. So I want you to solve this. And what do we need to do? Well, we need to cross multiply, right? No parentheses, so that makes it a little bit easier. We're going to go ahead now and just cross multiply. Use parentheses. Very, very important that you use parentheses. So when I rewrite this, I now have 2 times 4x plus 5 equals 3 times 7x minus 2. So there's that. Now, what are we going to now do? Distribute the 2 through, distribute the 3 through, and that's going to finish this out. So 2 times 4 makes it an 8x. 2 times 5 makes it a 10. 3 times 7 makes it a 21x. And 3 times a negative 2, well, that's a negative 6. Okay, and now we'll just rewrite this and rework it. So move that 21x over with subtraction. And we've got 8 minus that 21. 21 is negative. It's a larger number. So my answer is going to be negative. In this case, it's a negative 13. And then that's still plus 10 equals a negative 6. And my next step would be move the 10 over. And minus 13x equals now minus 16. And I'll slow down a bit. What's my last step here going to be? How do we finish this out? Last thing we always do is our division, right? Now, what happens when we divide by that negative? Yep, it makes it positive, right? Because negative over negative makes it positive. So we're going to divide both sides by a negative 13. And now we've got our final answer, which is x equaling 16 over 13. one more concept for this section is we can see if these fractions are equivalent. Sometimes it might be difficult to see if these fractions or if these proportions are true or not. So how do we tell if these fractions are equal? We have to cross multiply. So we want to see if these are going to be the same. True or false? Are these going to be the same? Yes or no? You decide whether the proportion is true or false. And let's do 8 over 24 equals 1/3. Okay, does 8 over 24, does that equal 1/3? Now, if we think about it, okay, what do we know about 8 over 24? Does that reduce down to 1/3? It does, doesn't it? Right? Because 8 and 24, well, 24 divided by 8 is what? 3. Okay, so that would reduce down to 1/3, right? But if I can't see for sure if it's going to reduce down, what do? Cross multiply. Now, if I cross multiply and they are the same, then it's true. And then 8 over 24 is the same as 1/3. So let's cross multiply and see if these are the same. If they're the same, if they're equal, then they should equal when we cross multiply. So 8 times 3 should equal now 24 times 1. Well, 8 times 3, what is that? 24. Does it equal 24? Yes. So that makes that true. Okay, so 8 over 24 is the same as 1/3. How about another one here? How about 63 over 315. Does that equal, how about 7/9? Is that going to be true or false? Are these fractions the same? And sometimes you might want to do this. Is 63 over 15, is that going to be the same as 7/9? Well, without using a calculator, how would you tell? Cross multiply. If they come out to be the same, it's true. They're the same. If they're not, they're false. So, what do? Cross multiply. When I cross multiply, I have 7 times 315, and that equals 63 times 9. Well, 7 times 315, that's 2205. And what about the other side? 63 times 9, well, that's 5 what? 67. Does that equal the other side? No. So those fractions are not the same. Now you can even have a fraction over another fraction. Okay, you can tell if this is going to be true or false as well. Same concept here. Again, true or false. We've got 1/2 over 5 equals 1 over 10. Are these the same? Are these going to be equivalent? How would I tell? Cross multiply. What does that give you? It gives you 1/2 times 10 equals 5 times 1. Well, looks to me like these are going to be the same because what's half of 10? Half of 10 is what? 5. And the other side is 5 times 1, so it's also 5, right? These are the same, so this is true. And let's do one more, just to make sure we have these down. How about 1/4 over 5 equals, how about 3 over 9? Okay, so we're going to try and see if these are the same. Cross multiply. And when I cross multiply, I've got 9 times 1/4. And the other side is 5 times 3. And 9 times 1/4, well, make your life easier. Just put this over 1. 9 times 1 is a 9. 1 times 4 is a 4. And what about the other side? 5 times 3 is what? 15. Do these look like they're going to equal? Does 15 equal 9/4? No. So this one would be what? False. Okay, let's talk quickly about our homework. I do have a sign-in sheet to pass out before we leave, and I have a couple of exams back to pass back and some graded homework too. So let me just talk about our homework. Now, for your homework, we did finish up 2.5, so you should be able to do them all. We did 2.6. You should be able to do all of those. And we did part of 2.7. Now, not all of 2.7. We did the equations in 2.7, not the applications. So for 2.7, you should be able to do 11 through 16. Those are just the equations. We will talk about the applications next time.